Good morning. I have here on my very messy office floor one of these Maser inverters that people use for load shedding. This came across my way. Somebody asked me to test it, clean it up a bit. This is still in working order. So what I've set up here is a little bit of a test. So on the left here you can already see the waveform that this thing makes. That, as you can see, is not a sine wave. That is what people euphemistically call a modified sine wave or a square wave. This is okay for most electronics these days, whichever switch mode power supply, televisions, laptops, it should be fine. But with some of your electrical motors or so, it might make it a bit noisy. These days the sine wave inverter is cheap enough. You just spend a little bit of extra, look for something that makes a sine wave. But there's some a bit more of interest down here. At the moment there's no load on this. So 235 volts, no load at all. This is a clamp meter. So we're doing about 2.7, 2.8 amps at no load. You multiply that by the 12 volts that are going in, you're between 35 and 40 watts of consumption out of your battery without any load at all. But now I already have a 60 watt incandescent lamp rigged here, so we turn that on. There's two things I want to check. What happened to this draw? So now we're very close to 8 amps there. 8 times 12. You can do the math there. That's about the same. But this is a bit more interesting. Look at what happened to our sine wave. This is now even worse. So this little guy, if you buy it now in the shop, it's about 2,200 Rand. But I would suggest spending a bit more. Get something that has a bit of a lower no-load draw and it makes a sine wave. And now, as a follow-up, I have another inverter here. This one has about a little under 3 times the cost of the previous one. Again, we can see on the oscilloscope here that this is a really nice sine wave. Now if you drill into these things, it's a bit difficult with one hand, but usually if you drill in a bit, you will see a slight step. This is not a sine wave like you would get from the grid, but it is pretty close, especially compared to the previous inverter we were looking at. Again, I have my clamp meter up and we can see the no-load draw of this, which is 900, we can say 1 amp. That's 12 watts. That's about a third. Yeah, it's a third of what we've seen with the other inverter. Significantly better efficiency at no load. Again, I have my incandescent lamp and I'm going to turn that on. And now you can see how much better we're doing. Your battery is going to last significantly longer with the same load because of what we're working with here. And then look at that sine wave.